Okay, so we're going to go ahead and start our next unit, and we're going to be working on a lot of solving and a lot of basically algebraic work, not as much graphing in this unit for those of you who don't like the graphing. Go ahead and take 10 minutes and work your way through these, pause the video, and then come back and we'll go through them together. Go ahead and pause it now. Okay, so you should have worked through the questions as far as being able to solve each one, and I know these seem, kind of basic maybe for some of you as far as, okay, why are we doing something this is like from, 8th grade and ninth grade? Well, because we're going to be doing a lot of solving, so we need to make sure that you're comfortable doing inverse operations. So, to solve this, you would subtract 11 from both sides. And I tell people who get stuck kind of on, what to do first when they're solving, is to read the equation, or read the equation starting with the x. So first you say, okay, what has been done to the x to begin with? When we were writing this equation, we would say 2x. Well, that means that x has been multiplied by 2, and then we added 11 to it, okay, to make it equal 24. When you solve something, or when you, well, basically when you're solving, you're undoing each of those, and it has to be done in that specific order. Think about it like getting dressed, okay? You put on your socks, that was the first thing that you did, and then you put on your shoes, it's the second thing you did. When you get undressed, you can't take your socks off before you take your shoes off. Okay, so you have to undo them in reverse order. So you're going to subtract 11 from both sides, and then you're going to divide by 2. Okay, so subtract 11 from both sides, and then divide by 2, and you're going to get x is equal to either 6.5, or you could have left it as 13 over 2. That's fine. No big deal. All right, so same thing on the next one. Again, if you think about the order in which things have happened to the x, if you're reading from the x, it literally, in order of operations says x minus 5, so we subtracted 5 first, and then we multiplied by 3. Really, I mean, if you're going from the x in order of operations, that's what you did. So that means the first thing we need to do is divide by 3 and then add 5, going again, reverse order. So divide by 3, and then add 5. Now, that is not to say that if you distributed that out and got 3x minus 15 and solved that way, you could have. That's fine. Okay, you would have gotten 3x minus 15 equals 18, right? And that's basically the same as the first equation. What have you done to the x? Well, first you multiplied it by 3 and then you subtracted it by 15. You're going to get the same answer. Okay, I just need you to be aware there is that way to solve this without having to distribute, and what we're going to be doing today with sine and cosine functions, you don't want to distribute that parentheses. Okay, so realize that you can undo without having to distribute first. Okay, so now we'll talk about something that actually, too far, doesn't have really numbers that you're solving for. You're solving for a variable. Okay, same rule. If I look at my W and I talk about what's been done to my W in order of operations, okay, so look at the W. First it's been multiplied by 2, and then we added 2L. Okay, so that means we need to subtract 2L and then divide by 2 on both sides of the equation. So I'm going to subtract 2L. So that's just P minus 2L. We can't combine anything on that. And that's going to equal 2W because that cancels. Then I'm going to divide both sides by 2. And I can either leave it like this, or if I simplify it, here's the deal, I'm going to have to write it as 2 separate fractions because that 2 goes under both pieces. So it would either P over 2 minus L, you could write it like that, or you could just leave it as P minus 2L over 2, which is perfectly acceptable when we start talking about trig inverses, which is what we're doing today. Okay, and this is all just like a refresher for you on using inverse operations because, that's what we're going to be doing. Okay, so make sure you have your paper ready. We're going to start working on inverses. And that means we're going to write inverses of the trig functions that we've already been graphing. Okay, those ones that had like all the transformations and stuff, we're going to start writing inverses of them. Okay, and it's basically like what you just did in the bell ringer. Okay, something that is really, really important when we're talking about this, when you are finding the inverse of a function, okay, what you are really doing is you're swapping the domain and the range, or basically the x and the y values, right? Because the domain is all the x and the range is all the y's. You're swapping them, okay? Finding an inverse, and this is true even for matrices and vectors and all that stuff. If we're inverting a matrix or we're inverting a vector, we're basically swapping the, for the vector, we're swapping the I and the j, which we did. We did several times when we were doing transformations. Okay, so that's really all we're doing is we're swapping the domain and the range, or the x and the y. Very, very important though that you think about it in terms of the domain and range, because we were already writing the range of the functions that we were graphing, right? The transformed functions. Okay, so what's going to happen is when you have a function and you have its inverse, those two things are going to be opposites. Okay, so like the domain of the first will be the range of the second. And it's actually pretty neat. We can find very easily, we can find the domain and the range of functions this way when they're inverses. All right, so let's take a look. We're going to do this graphically. I'll give you a minute. Go ahead and copy down the graph. We're going to start with the basic sine function. Oh, excuse me. Okay, so we're going to start with the basic sine function. Now, I've already written the domain and the range. Okay, the domain again being the x values and the range being the y. And everybody agrees if we look at one period, right, one full set of the sine function, it goes from 0 to 2 pi. Okay, and the y, the y values, the range goes from -1 to 1. We already knew that. What we're going to do is we're going to swap this, basically. Okay, so your new function, your inverse, the domain is going to be from -1 to 1, and the range is going to be from 0 to 2 pi. Well, how do we do that? Okay, we swap the x and the y values of the points that we know about. Okay, this is the point, right? This is pi over 2, 1. We know that. That's what that point is right there. That's the x and the y value. If I swap that, and I'm going to need my calculator, and so are you, we kind of have to know what the decimal version of pi over 2 is. It's about, what, 1.5, pretty close to 1.5, maybe a little bit more than 1.5. Okay, we're going to swap that. We're going to invert it. So that would become the point. Let's see. That would become the point 1 and pi over 2. Okay, well, where is 1? Again, this is just knowing the decimals. That's about 1.5. That's about 3. That's about 6. Halfway between that would be about 4.5. Okay, so if I swap this point right here, that's going to be about 1, right? And then we have to go up about 1.5. So it's going to be about right there. That becomes the point 1 pi over 2. Okay, so this point goes to here. Now, you might ask why I didn't do the 0, 0, because 0, 0 doesn't change. All right, so again, we're just swapping the x and the y values. So the next one is at pi 0. Okay, so that's going to be about 3, 0. So we have to go to 0, 3. All right, well, 0, 3 is probably about right here, right? Okay, so that's the inverse. So now our function kind of looks like this. Okay, it's curving basically upwards instead. If I keep going and I go to this one, which is 3, which is, let me get the right color, 3 pi over 2 negative 1, okay, and 3 pi over 2 is about 1.5. Our inverse point, and I'm going to run out of room, you know, somewhere up here, would be negative 1 and about 4.5. So that would be about way up here. Okay, so my function, as far as the inverse, is starting to look like this. Okay, and it's going to keep curving up the y-axis because this one, remember, if we were to keep going, it would keep bouncing back to 0. Well, so is this one. It's going to keep bouncing back to 0 on the y, whereas this one did it on the x. Okay, that's our inverse. All right, now if we wanted to write the domain and the range of the inverse, okay, and by the way, this is how you show an inverse of a trig function. Okay, if I wanted to state what the domain and the range would be of these values, my domain, my x values, well, this graph is going to bounce back and forth between positive 1 and negative 1, just like it did here for the x's. It's, or rather for the y's, it's now going to do that for the x's. So they literally swap. Okay, that means my range is going to be from 0 to 2 pi. Okay, and I'm going to show you what it would look like if I just were to graph that piece, because I want to show you why there's a problem here. Okay, so if I were to just graph just the inverse, okay, we know it's going to start at 0, 0. That doesn't change. Okay, and then it went out to what was it, 1 and up 1.5, right? Because 4, 5, 6, we're going to call that 6, that's about 2 pi. So out 1, up 1.5, okay? And then it gets to pi and 0, so that would be about right there, right? That's about 3, that's where pi is, okay? The next one is like negative 1 and then 4.5. 1, 2, 3, 4.5. So that's about right there. And the last one is going to be about 0 and then 2 pi and up 0. Okay, so this would be the actual graph if we were to graph the whole thing from 0 to 2 pi. Okay. Now I need you to notice something. There's a problem with this graph. Okay. And the problem goes back to something you learned in middle school, something called the vertical line test, right? And I know this is going to be a reminder. For something to be considered a function, right, it had to pass the vertical line test. Now what that meant was that, let me pick a good color. What that meant was that if you took a vertical line, right, any vertical line, and you dragged it across your function, right, if it ever touched more than one point at the same time, oh, and right there it touches 3, then it fails, okay? The short way of saying that, or the mathematical way of saying that rather, if something is a function, you cannot have 2 or more y values for the same x. Okay, so if we take a look at this function that we've done that was an inverse, right? I mean, right here at x equals 0, I've got 3 answers. I've got 0, I've got pi, and I've got 2 pi, right? So this fails the vertical line test. Okay, so we have something that we have to do to where we can actually still take the inverse of the trig function, right, and not have it fail. Okay, so let's take a look at our regular sine function again, and let's think about what we have to do. Okay, I've got it up here so you can look at it. Slide that down. Okay, so here's our normal sine function. If I were to take the inverse of the whole thing, we've already talked about it, it's going to fail. It's not going to be considered a function anymore. So basically, I take part of my graph, okay? I put a restriction on it. And I say, okay, I'm only going to find the inverse for a section of my graph that is only increasing or only decreasing the whole time, okay? And if you take a look, go back to, or think back to when you were graphing the basic sine and cosine functions, you had to tell me what each one was doing as you went through the graph, right? For the sine function, it was increase, and then decrease, decrease, and then increase again, okay? So with the normal sine function, no problem. If I limit it from here to here, my graph is only decreasing at that point, right? The whole time it's just going down. I can find an inverse here that won't fail the vertical line test, okay? And I can just swap those 3 points, those 3 x and y points, right? And I would be good to go. Because if I swap those, again, just those 3 points, here, here, and here, okay? We already know what that one is. We've done that one several times now. That's at 1 and 1.5, or thereabout. Okay, so that's the first point. Next one is 0 and pi, so that's right here. And the last one is going to be at -1, right, over here, and about 4.5. So that would be the inverse of this part of the function. And you would limit it by stating, right, that we are only using, basically we're saying on our domain, we're only going to use from pi over 2 to 3 pi over 2. Okay, so we're restricting it. And in that restriction, you know, pi over 2 to 3 pi over 2, my range is still the same thing as if I was looking at the whole function, right? That doesn't change. It's still going from -1 to 1. Okay, so let's think about what would happen on the new one. If we swap this just at this, you know, one section, here it is, we've graphed it. The domain of my inverse is now from -1 to 1, and my range is now from pi over 2 to 3 pi over 2. And that would be it. Okay, so graphically, again, you take the graph, you choose a section of the graph where it's always going down or always just going up, okay? That's going to be your domain that you're restricting it to. And then you swap the x and the y points. And that means that you're going to have to get some decimals in your calculator for things like pi over 2 and pi and things like that. But it's actually very, very easy to swap once you've restricted it, because again, all you're doing is swapping the x and the y points. That's it. All right, so let's have you try one. I'll give you a few minutes. You try this one, and again, you've got 2 different possibilities for this one because you could either choose this half or this half. Okay, and I'll do both. I'll give you a couple of minutes to work on which one you want to do, and then I'll come back and do both, and you can check your answer. Okay, so I'm going to start with the first half. Okay, if you restrict to this part right here, then the domain of that is from 0 to 2 pi, right? And the range is from -1 to 3. Okay, so I now know what the domain and range of my inverse function should be. Okay, so I'm going to just swap my points. All right, so if this is the point 0, -1, then that becomes the point -1, 0. Okay, -1, 0. And then this point right here, pi 1, becomes the point 1 pi. So I go over 1 and up about 3. It's about right there. Okay, and then the last one is 2 pi 3. So that becomes 3, which is about pi, and then 2 pi, which is about 6. So it'd be all the way up here. Okay, and that is my inverse function. So for the inverse, right, the domain is going to go from -1 to 3, and the range, because of where we chose to stop it, is going to go from 0 to 2 pi. And that's what the inverse would look like. Okay, so if you chose the other side, right, I'm going to do the other side in, how about pink, so people can see it. Really, really bright pink, if I can find a good pink one. There we go, there's the pink. Okay, so let's just say that we're going to do it from this side. All right, so from here to here. Oh, that's not bright enough. Maybe that will be. Yes, okay, that's much brighter. So on this one, right, the domain would be from 2 pi to 4 pi, right? And the range would still be from -1 to 3. That doesn't change, because if you're picking something that is decreasing or increasing over the whole way, then you're still going to get like the entire range of the function. Okay, so I want to swap them. So I'm going to swap these 3 points. So we're going to start with, again, 2 pi 3 becomes 3 2 pi. So that point wouldn't change. It would still be there. Okay, so the next point is 3 pi, which is about 9 up 1. Okay, so 9 1 becomes basically 1 9. And I'm going to run off my graph at this point. Let's see if I can slide this down a little bit. Slide you down. Okay, so I'm going to run out of room on the top of my graph. 6, 7, 8, 9. Yep, definitely going to run out of room. So the original point, pull that back down here, is still there. Okay, and that was 2 pi 3, so that becomes 3 and 2 pi, which is about 6. All right, so the next one, like I said, is 3 pi, which is about 9 1. So we go 1 all the way up to about 9, so that's right here. And that part, as far as like the inverse of that, is going to go that way. And it's going to go off the top of my graph that way. But again, all we're doing is graphing those 3 points. And then we can rewrite the new domain and range. The new domain is -1 to 3. And the new range is from 2 pi to 4 pi. Okay, now that's the limit as far as what you'll be required to do graphically, is to take a portion of a function that's already graphed and just swap the x and the y points and, and state what the new domain and the range are. Now, for those of you who don't like the graphing, and I get it, it's fine, we do have an algebraic method. Okay, and here's the algebraic method. You first need to know what the period and the domain and the range of your graph, what they're going to be, so that you can figure out what you're going to limit it to. Okay, so all that stuff that we were picking out before hasn't gone away. We still need it. So what is the period of that function? Well, if b is 1, right, 2 pi divided by 1 is 2 pi. Okay, so the original domain for the whole function would be from 0 to 2 pi. We don't want that. Okay, remember, this is a cosine function. And if it's going from 0 to 2 pi and it's positive, then it's going to go, what, down and then back up? Right? So down and then back up. So I only want half of that. So you need to either pick the first half or the second half as far as what you're going to restrict your domain to. Okay, so I'm going to take the first half. I'm going to say that my domain that I'm going to pick is from 0 to pi. Okay, and the range of my function right now, remember the shortcut way of finding the range, the d plus or minus a? Okay, so -1 plus or minus 2 gives me a range of from -3 to 1. Okay, so -1 minus 2, -1 plus 2. So we have our domain and range of our original function. So we know what the domain and the range of the inverse is going to be. Let's see if we can write it, okay, instead of having to graph it. So there's our original function. The first step to finding an inverse is to swap x and y. Okay, so we literally take that x and take that y and make them trade places. Oh wait, that's supposed to be a y. Let's try that again. There we go. So we make them swap places. Okay. Now we're going to use inverse operations. Here's where the bell ringer comes back in. We're going to try and solve for y. Okay, so we need to talk about, just like we did, on the bell ringer, what has been done to that y value in order, right? Because, order of operations actually does matter. So the first thing that we did to that y, if we're reading this, is we took the cosine of it. And believe it or not, that's an actual operational step. And we're going to talk about undoing that. Okay, so we took the cosine of it. Then we multiplied it by 2. Then we subtracted 1. Okay, so in reverse order, just like we did in the bell ringer, we're going to add 1, divide by 2, and then here's where, when I was talking about how you write an inverse function for cosine, or for basically for trig, is you say to the -1. You raise it to the -1 power. Sort of like we did for matrices when we were doing inverses of matrices. It's the same thing. That is a short way of saying an inverse. So let's actually do these steps on both sides of the equation, and you'll see what happens. I'm going to add 1. So now I have x plus 1 equals 2 cosine of y. Okay? Now I'm going to divide by 2 on both sides. Okay, and this is where we were talking about leaving those as like a stacked fraction, and that's okay. You can do it that way. So I have x plus 1 over 2 equals the cosine of y. And the last step is to do the inverse cosine on both sides. Well, if I take the inverse cosine over here, cosine times cosine inverse, I'm just going to get y. It's like it cancels itself out like any other inverse operation. The other side, I just get to write it as x plus 1 over 2. Let's write that a little bit neater. Now, if you want to separate that into two fractions, you can. It's not a requirement. That would be 1/2 x plus 1/2. And no, that would not be on the outside of the parentheses for a very specific reason. When we took the cosine of it, we took the cosine of the whole thing, so that whole thing is in the parentheses. Okay, and I can look at this and go, okay, my domain for this function is going to be from -3 to 1, and my range is going to be from 0 to pi, if I were to actually graph this. And you can actually put this in your graphing calculator. You could put both of equations in there And you would see that one reflects the other as far as swapping the x and the y points. All right, so let's try a sine function. Okay, so go ahead and copy this one down and we'll talk about what this thing looks like so that we can take half of it. Question is, which half? Because it's not going to be the first half or the second half anymore because of the way a sine function looks. So, period, 2 pi divided by 2 is going to be pi. Okay, the domain, well, we'll talk about that. This is a sine function, right? Okay, and this is a sine function, first off, it's only going to pi. It's been moved up 1, which doesn't really matter as far as the domain goes, but it's been moved up 1 and then it's stretching by a half. So it's going to look like this, or thereabout. Okay, here's the thing. 3 pi over 4. I'll try that one again. And pi over 4. And again, this is why graphing these was so important in the last unit. Notice the way a sine function works is it increases and then it decreases twice and then it increases again, right? So we're going to pick, like I did in the original sine function, the middle half, okay? So we kind of need to know the middle half since it's a sine function rather than the first half or the second half since, if it was a cosine. We're going to take the middle of it. Okay, and again, this is why being able to graph these and knowing how to split up the x-axis like you're supposed to. I got on several of you about this, about not drawing your x-axes correctly based on your period. So if your period is pi, okay, that means that you're going to want those middle pieces, right, those two middle pieces between them, as far as where you're going to restrict your domain to. So this is going to be pi over 4 to 3 pi over 4. That's my new, or my restricted domain. The range is going to be what the range always is, which is 1 plus or minus a half. So that's 1/2 to basically 3/2, or 0.5 to 1.5. Your choice. So decimal or fraction. Okay, so you are going to need to be able to write this, right, so that you can state what the domain and the range is of your inverse function. Kind of important. All right, so let's do the algebra. We're going to swap x and y. Notice I did not take the 2 with the x. All I took was the variables. That's it. Okay, same as before. What have I done to that y? Well, in this case, starting from inside where the y is, I've multiplied it by 2, right, 2y, then took the sine of it, then multiplied it by a half, so we're going to have to divide twice on this one, and then I added 1. Again, order of operations, that's 2y, the sine of 2y, 1/2 times the sine of 2y plus 1. Right? You have to think about what's been done to the y first and work your way out. So inverse operations, -1. Well, we can make this a little bit easier because, multiplying by a fraction, instead of dividing by a fraction, we can say we're going to multiply by the reciprocal, make life a little bit easier. We're going to multiply by 2. That's the inverse of multiplying by a half. We're going to take the inverse sine, and then we're multiplying by 2, so we're going to divide by 2. And again, in reverse order, very, very important. Okay, so first, subtract 1. So x minus 1. Okay. And then, so that takes care of that one. Now I'm going to multiply both sides by 2. If I multiply by 2 over here, my half goes away. If I multiply by 2 over here, I either need to distribute or put parentheses like that. Your choice. It's not a requirement that you actually multiply it out. Okay. All right, now take care of that one. Now I need to take the inverse sine on both sides. Okay. And that's going to give me 2y. And then I divide the whole equation by 2. Well, which is the same thing as multiplying by a half, right? Those inverse operations. So again, this is a choice on how you want to write this. Several people, don't like having that big fraction in there. If I divide both sides by 2, then I'm going to get this big fraction, which is fine. There's nothing wrong with that. If I do the reciprocal, then I'm basically going to have y equals 1/2, which looks more like the stuff that we've been graphing already, where it has the a in the front of it basically, because that's really what that would be your amplitude. Okay, and that is what you are going to be doing today. All right, if you have questions, send it to me through Remind, that's fine. Your assignment, here's the deal, okay? You're going to go into section 4.5 of your textbook. The online version is fine. Section 4.5. Now, I don't want you to pay attention to the directions in the textbook. Here's the thing. I want you to use these as functions, okay? It's just 6 functions that I want you to use. I want you to figure out the inverse of it, going through the steps we just did. And then I want you to just state the domain of the inverse. Okay, not even the domain and the range, just the domain. Okay, so you should have some time before you leave class today to go ahead and get this going, because some of you are really, really bad about doing homework, so might as well do it now. All right, talk to you later.